Jim Carroll, Ralph Weber, you need a dose of real. Life's absurd. We know the deal. TIGR, don't let it get you down. Turn that
Well, Ralph, it seems like this winter is kind of upside down.
It does.
Some days are relatively warm at 32 degrees. Other days like today have a wind chill factor of negative 29.
Yes, and the wind chill sneaks through your heavy-duty winter clothing and chills you to the bone.
Mm-hmm. Makes you real kind of cold and crispy, right?
It does, which brings us up in a very punny way
To CRISPR.
which is our topic for today.
Right.
Now,
Remember that we did, I think it was during Neuron Week, which would have been probably 2019 or so, that we did a whole week looking at neurological, developments and CRISPR, which was at that point in time 10 years old. Remember that? Yeah.
and at that point, a lot of people had not heard of CRISPR, and if they'd heard of it, it was some sort of vague little news article in the bottom section of the paper.
Yeah. It had nothing to do with crispy potato chips, did it?
No.
Yeah.
And the thing is that, it was one of those kind of, well, not fringe element of science, but one of those things that had not hit the news.
Right. I think it was 2009 that it was discovered, and the discoverer, Ye Feng, really didn't know what it was all about. He knew how to do something, but he didn't know what the effect of that something might be.
And that's often the case, just to interrupt you for a second, with researchers in what's called pure science.
Basic research, yeah.
They find something, but they have no idea other than, hey, this is kind of cool and interesting. They have no idea how it might turn into something useful.
Mm-hmm. Yeah.
So that's 2019.
Yeah.
So here we are, by my weird count, 7 years later.
Okay.
So it's a piece of science, which is basic research. We know it's cool. We don't know what it might be useful for.
Well, we've come a long way in those 7 or 8 years.
Yeah.
The first people that really did a job with CRISPR were the two female scientists who won the Nobel Prize. And their names escape me right now, but even then, the idea of what it was going to do wasn't really clear. And in fact, if we take a look at a timeline, up to about 2015 or so, we had this notion that CRISPR is going to cure all diseases. Well, that hasn't happened. But
and unfortunately, right at the moment and for the foreseeable future, we can pretty safely say CRISPR is not going to cure all diseases.
Right. We'll talk a little bit more about that from a psychological point of view in just a second. Yeah. And then there was the, the ethical / scare of CRISPR doing things like cloning human beings. Remember that one?
Yes, I do remember that one. And that was just at the time, and it really had nothing to do with CRISPR per se, but that was just about the time that we had a cloned sheep.
Dolly the sheep.
Dolly the sheep.
Mm-hmm.
And so people said, well, if you can do that with a sheep, you can do it with a human being.
Yeah. And I think somebody over in China, a doctor or a scientist there, actually did a little genetic modification in a couple of twins, right?
Yeah.
Yeah, who had some kind of genetic disorder. I don't know what it was, but that really caught the attention of people who said, "Woo, that we're into this brave new world." Well, yeah. In 2026, CRISPR is a medical treatment. It's not broadcast all over the front pages of the major newspapers, but indeed, it is here to stay. It's kind of like the internet, Ralph. People didn't really understand what the internet was all about when Al Gore invented it.
Right.
But now we can't get along without the internet.
And the thing about the internet, Jim, is, it has gone from a wonderful thing to a frightening thing to a wonderful thing to now in 2026.
A wonderfully frightening thing.
A wonderfully frightening thing because of what is thought as one of the two major things that are frightening for 2026, AI.
Mm-hmm.
And now it is getting seriously hard when you look at something on, a source like YouTube, to say, is this a real person who is speaking to me, or is this something generated by AI?
You mean if people who are looking at us on YouTube might be saying, "Oh, Baber and Carol, they were probably generated by AI, and they look so good, they sound so great, they must be AI."
I wish that was the case because then we would be making money off of YouTube as opposed to doing this as our contribution to world knowledge.
Indeed. Yeah. Now, we're going to work on this together, Ralph. The term CRISPR.
Okay. Is
CRISPR.
Right.
Now, the last R stands for real, and the first one stands for clustered. So clustered and real.
Repeating.
Yeah.
The I is...
I've got my notes here. Let's see. Oh, interspersed.
Interspersed.
And then you have...
Short.
Okay, then both of us have this one last...
Palindromic.
Palindromic. Okay, good. As a English scholar, you know what that means, right?
Right.
Okay. So you put them all together and you got CRISPR.
Right.
Okay. Now, what exactly is CRISPR going to do? It isn't going to cure all disease.
No.
It's a gene splicing thing. And so Sheila was asking me today, now, how exactly does it work? Well, I'm not 100% sure. And you'll see a link under Learn More in our show notes that will take you to a little video, actually a 20-minute video, on CRISPR and then the sort of new evolution from CRISPR, that is TIGR. And
Okay.
they explain how CRISPR works. But as I see it, we've got a double helix of DNA,
which
right, has all of the blueprints of, for you and I, the color of our eyes, the color of our skin, maybe how tall we're going to grow, maybe how large we're going to become, and maybe some disorders of some kind, like, let's see, sickle cell anemia is a genetic disorder.
Okay.
So that could be there in the DNA also. And so go ahead.
Well, one of the things that this CRISPR does, and apparently the original unit of CRISPR is 9 units or 9 individual pieces.
Yeah, okay, you can look at 9 pieces of something.
And that goes into the gene.
Mm-hmm.
And it links to the associated 9 pieces. And then through something indistinguishable to the average layman from magic, but basically science-based, it changes them.
Yeah.
So if you are subject to sickle cell anemia because of a genetic mutation, CRISPR can go in and say, we are going to kick that mutation to the curb.
We're going to take it out, put in a good gene sequence that will cover that, right?
Yeah.
So
And
it's like scissors in a way. You're
Yeah.
taking something out, taking the bad out, and putting something
putting a
new in.
good addition in.
Yeah.
So a
You're
good
not-
addition in this case means normal. It
Yeah.
means what people who don't have the mutation for sickle cell sickle cell
Easy for you to say. Sickle cell anemia.
anemia. Anemia. Yes. Anyway, so people who don't have that, they can say, okay, this is what my gene is like. People who do have that, they can say, oh, my gene has a mutation. That's not good. But CRISPR can come in and take out that mutation.
Yeah. So the big part then is to find it in the first place, right? To find
Right.
the area in the double helix that is damaged, and then take it out and then put the new back in. So it's a very complex kind of thing, right?
Right, it is. And the thing about that is it's complex and it can be expensive. So, we find still a lot of trials with this for, things like beta theisma,
That's another blood disease. Yeah.
another blood disease. That can be successfully treated in human people, but on right now, pretty much still a lab level because it's not something that your average Medicare can afford.
Okay. And your doc, at the clinic down the street, probably doesn't have access to this, unless maybe at some point it'll be something that's, I don't know, injectable.
Yeah.
Who knows?
And that kind of is the direction that we're going in, is to get things which are CRISPR science, but can be effectively and affordably administered to people.
Yeah. Now, you mentioned the cost of it, and I was thinking about that myself. A lot of universities have probably the labs that are doing the work. I know that I think Stanford was doing the work originally on CRISPR. I know MIT is doing the work on this new thing called TIGR. Now, with funding cutbacks, is that going to directly affect CRISPR? So I dug around, and it will, but it's not targeted at CRISPR. It's not like there's someone in the government who says, okay, we're going to stop funding this thing because, it's kind of, I made the analogy of the internet. Well, CRISPR is kind of like the internet now. I mean, it's there.
Yeah.
Yeah, so we have to learn how to use the thing.
And the thing to me, Jim, that a lot of these things that were or are going to be defunded, they are so far mostly aimed at people who had, for lack of a better term, I'm going to say, not pure science, but not applied science. They were kind of people who had, I want to do research in, and they'd put down a topic when they applied for funding. And somebody reading the topic would say, I don't see this adding to the basis of scientific knowledge, and I don't see it adding to applications that can be used. You can argue that that's short-sighted, but because nobody sees basic research as being heavy utility,
Right. Right.
you know.
It's kind of like the invention of the electricity. I mean, nobody would have seen what we have now in terms of being, electrically wired in throughout the United States and the world. So every time there's a new invention, there will be somebody who's going to be scratching their head and saying, look, our buggy is perfectly good. The buggy whip is fine. We don't need this thing called an automobile, do we?
And the answer turns out to be yes,
You bet your boots we do.
except if you live in somewhere like Los Angeles and you look at a stream of 6-lane highway filled with cars who are all stopped because of an incident 2 miles ahead, and you're saying, do I really need to be in my car for 45 minutes longer?
This is the motivation for flying cars, right? Like
Right.
the Jetsons,
So,
which we might have also. Who knows?
Yeah. So the thing is that you can never know from basic research where things will go.
Mm-hmm.
But what we know now about CRISPR, there are two things that I think are really interesting and important. One of them is that CRISPR can take care at the moment of some genetic disorders.
Yeah.
And we're trying to apply it to things like cancer treatments,
Mm-hmm.
which we all know heart problems and cancer are the two leading causes of death
Mm-hmm.
in North America. So, can we fix heart problems? Well, we're doing some basic research in that area.
Yeah.
Can we fix cancer problems? Well, yeah, maybe some of them,
Yeah.
sometime.
Ralph, the area with CRISPR where we've seen the most success is with agriculture.
Yeah.
It's helped to construct, I guess that's the right word, drought-resistant strains of wheat, early wheat or barley or something that grows more quickly than usual. And there are half a dozen different applications.
Yeah,
But
no-
we're a little bit questionable about human health. And you know why that is?
Because it's humans.
Because it has to do with humans.
Yeah. Now, here's the other thing that I was going to say, Jim. The other part of CRISPR that applies to agriculture is so many people run around and say, I'm never going to go to my grocery store and buy genetically modified organisms.
GMOs, yeah.
GMOs. But here's the thing. There is no difference between a genetically modified organism in agriculture and what happens in nature. Nature modifies the genes of plants and animals.
Mm-hmm.
The only problem is that in order for nature to do that, it might take 100,000 years.
Yep.
And with genetic modification that we can tailor,
Yep.
we might be able to do it from one generation to the other.
Mm-hmm.
Well, if we're trying to feed billions of people,
It makes some sense, doesn't it?
it makes some sense because we can say, you know what? We don't have 100,000 years to sit around and wait for Mother Nature to
Give us better wheat.
give us better wheat.
Yeah, right.
So we have to say, can we do this and carefully think about what are the downsides?
Mm-hmm.
So when I said, we talk about AI, and that's one of the big fears of the world right now, or at least the Western world, is AI is going to be pernicious. Well, it certainly has pernicious problems. But it also has things that can help to solve problems that are otherwise insolvable.
Mm-hmm.
So you look at somebody's picture online and you say, is that real or is that AI? It's hard to tell.
Except our viewers know that we're real, right?
Anybody who has tried to hear me pronounce thalassemia obviously recognizes that.
Okay. Yeah, so it's interesting, Ralph. You mentioned AI being one of the things that kind of threaten people. In my developmental psych class the other day, we were talking about anxiety in young kids. And you might think, well, when I was 2 or 3, I didn't have any anxiety. No, you didn't, but your parents did, and it passed it on to you. And I said, are any of you, anxious about AI? And about at least half the class stuck up their hand. So this week, Ralph, is a milestone for the setting of the doomsday clock.
Okay.
You've heard of that one, right?
Yes, the doomsday clock is a clock that heads towards midnight.
Yes.
And
At midnight, the world as we know it will come to an end.
come to an end.
Uh-huh.
Now,
My students, when I talk to them, they say, nobody knows when it's going to come to an end.
well, here's the thing. When the doomsday clock was originally put in place, it was right after the development of and use of the atomic bomb.
Right.
And
So
so
we were-
people said, okay, well, we now know that you can eliminate whole cities with one bomb. What would happen if the West and the Soviet Union went to war?
Right. And growing up in the Sioux, they prepared us for that too, didn't they?
They did.
Showed us how to hunker down under our desks with our hands on our head, right?
Right.
Okay, because we were a prime target.
And
But it didn't happen, thank
it didn't
heavens.
happen. Now, the thing is that you say, well, okay, so now we've got problems in the Mideast, we've got problems in Europe, we've got problems in China, we've got problems in the U.S. Are we getting closer and closer to where some mad person hits the button?
Mm-hmm. And it's interesting, though. None of those were mentioned by the group of scientists. The things that they mentioned, 2 things they mentioned, were AI. I mean, I'd take a look at the geopolitical stuff and say, yeeks. But they mentioned AI, and they mentioned, let's see, one other one.
Climate change.
Climate
Catastrophe.
fear. Climate catastrophe, yeah. Which, sitting here in Mount Pleasant, I'm not sure I can help very much with either one of those.
Yeah, and the problem that a lot of people don't seem to realize is that yes, the climate is changing,
Right. But it's always changed.
but
Yeah.
it's always changed. We had the little ice age in the 1700s.
Mm-hmm.
Europe fell into a very bleak period because crops were failing over a period of about 100 years, from 17 something into 18 something.
Mm-hmm.
And you say, well, why would that be? Well, because for whatever reason, there was a little ice age that changed the climate for about 100 years.
Mm-hmm.
Now, this is well before any man-made effluents were coming out.
Yeah.
So you say, well, yeah, that happened. Well, there was also if you go back a couple of million years, there was also the Holocene warm climate.
Mm-hmm.
And you say, okay, well, that was a period of great warmth.
Yeah. So we have these cyclic kinds of things. But it's easy when you see a cyclic thing from a 2 or 3 or 4 year period, like even a 2 or 3 week period. This summer we were talking about global warming, here in Michigan. Hey, if you came to Michigan today and walked around the streets, you better have your long underwear on because it is cold. So now we've got an ice age coming. This summer we'll probably be back to the global warming thing.
Global warming thing. And, here's an interesting thing while we're on the topic of AI. AI, under the auspices of Grok, Grock, which is one of the AI systems.
Yes.
Grok was asked, take all available data and look at your estimate of, has the globe warmed significantly in the last 300 years?
Mm-hmm.
Grok looked at all available data and came up with the answer, yes, it has, by 0.1%.
So small difference.
Small difference.
Yeah. We're going to be talking about, or we've been talking about CRISPR, but I'm going to mention one thing, and that is TIGR.
Okay.
The same fellow who did the original research with CRISPR has done some research with a more sophisticated gene editing tool, faster and more accurate. And he calls it TIGR, and I can't remember what the acronym TIGR is. But he is on this video that is down there under Learn More, and he's fascinating. The video is a little longer than most of you are going to want to watch. It's about 20 minutes or so. But the scientist, the marine scientist, goes into his lab, and they look at what he's actually doing now. Now, he got his PhD in 2009. So you calculated he's probably in his 40s by now, right, Ralph?
Yeah, mid to late 40s. He still looks about 19.
He does. And the thing that's really interesting, too, is that he's so enthusiastic about what he's doing. I mean, he really loves going into the lab and doing science. And, so you and I like kind of applied stuff where we come in and we talk about things. But he's in there, cutting genes apart and stuff. And he, like with CRISPR, he's not sure exactly what is going to come of this, but he keeps him going in the morning, which I think is, kind of good.
And one of the interesting things to me about TIGR is that the length of DNA that TIGR cuts is shorter than CRISPR.
Yeah, but CRISPR's 9, TIGR's like 1. Yeah, they can really focus in.
So you can focus in and you can cut out smaller snippets, so you might not have to take out all of the mutation for sickle cell anemia, which we talked about. Mm-hmm. You might only have to take out the one part of the mutation that causes it to spread.
Mm-hmm.
So it's maybe more effective in another 5 or 6 years.
Yeah. I don't know if we'll be around, Ralph, to see the effects of AI and CRISPR and TIGR and climate change, but hey, welcome to the mid part of the 20th century. 21st century.
21st century.
What happened to the 20th century? Well,
we grew up in it.
Yeah, we grew up in it. Okay. Hopefully we're still growing up.
I'm still looking to figure out what I'm going to do when I become an adult.
When you grow up. Yes.
Yeah.
Okay. Until next time, this is Jim.
And Ralph.
Saying, keep your stick on the ice.
Because we're all in this
together.